In this problem, we have a running back running toward the goal line with a speed of positive 8 meters per second because it's to the right. We have a linebacker running in the other direction to try and stop him, so his speed is going to be negative 6 meters per second. They collide, and the linebacker attempts to tackle the running back, and then they move as like one large mass of bodies, so we know the speed of the running back after the tackle is going to equal the velocity or speed of the linebacker after the tackle, and since they're going to be equal, we'll just call that a generic v prime. We know the masses, we know the initial speeds, and from that we should be able to figure out what happens in this problem. We're going to be using conservation of momentum, so I know that the momentum of the running back plus the momentum of the linebacker has to equal the momentum of the running back after the collision, so that would be, that's why there's a little prime there, plus the momentum of the linebacker prime or after the tackle. I'm going to expand the momentums into what makes up momentum, which is mass times velocity. So mass of the running back times velocity of the running back plus the mass of the linebacker times velocity of the linebacker is going to equal mass of the running back times velocity of the running back prime plus the mass of the linebacker times the velocity of the linebacker prime. Now we don't have any zeros in here. We have nothing to cancel out. There is a speed of the running back before the collision. There's a speed of the linebacker before the collision. And we're not sure what the speeds over here are, but that's what we're going to try and find. So I'm going to simplify my equation a little bit on the right side, since I know the velocity of the running back and the velocity of the linebacker after the collisions are going to be the same. So my left side of the equation remains unchanged. I have mass of the running back times velocity of the running back plus mass of the linebacker times velocity of the linebacker. But on the right side, what I'm going to do is I'm going to change the velocities. Instead of velocity of a running back and velocity of a linebacker, both prime, we know they're the same thing. So I'm just going to, as I said earlier, change that to the generic v prime. And what that does for us is it really emphasizes that we're really only looking for one variable, not two. Now we just have to do a little bit of algebra to solve for that velocity prime. I have it in two terms on the right side, so I'm going to factor it out. So on the left, again, remaining unchanged, mass of the running back, velocity of the running back, plus mass of the linebacker times velocity of the linebacker. But on the right side, I factor out my v prime, and in parentheses, I'll have mass of the running back plus mass of the linebacker. Now I'm going to divide by those masses. So on the left, I still have mass of the running back times velocity of the running back plus mass of the linebacker times velocity of the linebacker, but now I'm going to divide that by the mass of the running back plus the mass of the linebacker. Once I plug in all those numbers, it should give me v prime, or how fast they're moving after the collision. So plugging in my numbers, I get 75 kilograms times 8 meters per second plus 110 kilograms times negative 6 meters per second. And that's all divided by 75 kilograms plus 110 kilograms. And when I plug all that stuff into my calculator, I'm almost out of room. I'm going to write it down here in the bottom left. When I plugged it into my calculator, I get that v prime equals negative 0.32 meters per second. And since it's negative, we know that it must be going in the left direction. And since it's going in the left direction, there is no score. The running back gets stuffed at the line.